Welcome to IB.
I'm back. So for today, we're going to talk about geometric sequence and series. Let's have first the geometric sequence. This is a special type of sequence where each term after the first is obtained by multiplying the preceding term by a fixed non-zero number. And the fixed multiplier is called the common ratio, denoted by small r. It is called the common ratio because it is the ratio of any two consecutive terms in the sequence. Again, any two consecutive terms. So the formula in getting the ratio will be r is equal to n term plus 1 all over n term. The formula in calculating the n term in a geometric sequence is last term is equal to first term raised to the power first term multiplied by the common ratio raised to the power of the position of the term minus 1. That is the formula. So these are the steps to calculate the n term of a geometric sequence. So the first one is we need to identify the value of the first term, or a sub 1. Second step will be we need to find the value of the common ratio, or the r. And of course, the last step will be apply the formula. So let's proceed with an example. Find the fifth term of a geometric sequence where the first term is 5 and the common ratio is 3. So the first step is we need to get the first term. So in this case, our first term is 5. And our common ratio will be 3. And the nth term, we need to find the nth term. And of course, the position term is 5. Let's write the formula. So the n will be 5. Raised term is 5. The ratio will be 3 based on the problem. And then 5 minus 1. The answer is the answer will be 5 times 81, 405. So our fifth term will be 405. Next example, number 2. Find the 10th term of the geometric sequence for 1236. So again, our first step for our solution is to find the first term. So in this case, our first term is 4. What is our r? Again, when we say common ratio, it is the ratio of two consecutive terms. So this is our first term and second term. So what is the ratio? Okay, so let's say the formula in getting the ratio is a n plus 1 all over a sub n. So our a sub 1, let's say 4, and our a plus 1, a sub 1 plus 1, or a, the second term is 12. So let's put it based on this, right? And then there you go. So 12 divided by 4, our R is 3. Next, and our N is 10. Very good. 10 because we are looking for the 10th term. So let's proceed with the formula. Again, the formula for geometric sequence. So this will become 10, 4 times 3, and minus 1, 4, 3 raised to 9, 4 times, what is 3 raised to 9? $19,683. So our 10th term will be 78,732. Next example. The fourth term of a geometric sequence is 64, and the ninth term is 486. We need to find the common ratio, the first term and the seventh term. Let's proceed. So this is the solution. Let's have first the fourth term from. So in this case, we have 64 or 4 minus 1. That is from the A4. So this is A4 is equal to 1 R n minus 1. Let's proceed. So in this case, we have here 64 is equal to first term ratio 3. Alright. Now let's move on. What about from ninth term? From the ninth term, let's do it. 9, 1, and minus 1. So this will become 486. 1, 9 minus 1, 486. First term. This will be our equation 2. This is our equation 1. This will be our equation 2. Our next step is to divide the equation 2 by the equation 1 in order for us to solve for the common ratio. Okay, let's focus with the common ratio. So in order to get that, let's divide them. 486 and then 64 is equal to all over. Now we can get the value of our R. So with this, it could be like this, and this is cancelled out, the value is 5. And get the fifth root. So the answer will be 3 over 2 as our ratio. Okay, so that is our letter A. Now, what about the first term? For the first term, this is a letter B, first term. So let's substitute the formula in the equation 1. So 64 is equal to, the radius will be n minus 1, 4 minus 1. So 64 is equal to 3 over 2 raised to 3. And the answer will be 64 divided by 4. And in this case, we're going to divide this one by 4. 27 divided, cancel the out, so our answer will be 512 or all over 27, and this will be your first term. What about letter C, the seventh term? Letter C, seventh term. So let's proceed. So we have our first term, 512 or over 27. Our R, 3 over 2. Our N, 7. And we need to look for the N term. So the formula, first term Rn minus 1. This is 7. 512 or over 27. 3 over 2 raised to 7 minus 1. Continue the process. 512 all over 27. 3 over 2 raised to 6. So the answer with that, and my answer will be 216 for letter C. Okay. Let's move on. Let's apply what we have learned into a word problem. So the problem goes like this. A local farmer named Bang Pedro started raising native chickens. In his first month, he had 3 chickens. Every month, the number of chickens tripled as each chicken hatched more chicks. The number of chickens each month follows a geometric sequence. Problem. How many chickens does Mang Pedro have by the 5th month? Second question, how many chickens does he have by the 8th month? Last question, write the general formula to find the number of the chickens in the nth month. So let's write all the given first. Based on the problem, The first term is we have 3 chickens. 3 chickens. And the common ratio is tripled. The chickens tripled every month. So we have 3. Let's proceed with the question number 1. How many chickens does manufacturer have by the 5th month? 5th month. It will be A sub 5 is equal to, let's follow the formula, A sub n, A sub 1 ratio n minus 1. So with that, our n will be 5. So let's proceed. Our first term is 3. The ratio is 3. And minus 1, 5 minus 1. So the answer will be 243 chickens. So 243 chickens will be the answer for number 1. Let's proceed with number 2. How many chickens does he have by the 8th month? So same process, 8th month. In this case, our n will be 8. The formula to be used still the same. This will be 8 and our first term is 3. Our ratio is 3. 8 minus 1. This must be 8. So 3. What is 3 raised to 7? 3 raised to 7 is equal to 187 multiplied by 3. We have 6,561 chickens. That is for number 2. Let us try number 3. We need to write the general formula to find the number of chickens in the month. So in this case, for number 3, we know that our first term is 3 and our ratio is 3. And our formula will be A sub n, first term multiplied by the ratio raised to the power of n minus 1. So in this case, our general formula will be this one. Alright, so that is about geometric sequence. Let's talk about geometric series. So this is the formula for the geometric series. S sub n is equal to A sub 1 or the first term all over 1 minus the common ratio. It is where the A sub 1 is the first term, the R is the common ratio, and the S sub n will be the sum of the first n terms. So let's try some examples. Find the sum of the first 5 terms of the geometric sequence. So let's write all the given. So our A sub 1 or the first term is 2. And obviously our ratio is 6 divided by 2. I say 6 divided by 2. 6 and then 2. We have 3. Our n is, we are looking for 5 terms. So we need to find for the S sub n or the sum. The formula is S sub n 1 minus r. So let's substitute the formula. 5 first term is 2, 1 minus